Okay, example problems for section 11.5. Okay, we need to find the area of the sector. It's not shaded, but that's okay. We are going to leave our answers in terms of pi. I wish the book did more of this. Basically, this means you are not going to touch your pi button. Every time you want to touch it, you're just going to keep the pi in the problem. Okay? Once again, the formula, this is a sector that I'm trying to find. So area is n over 360 times pi r squared. My n value is 120 degrees. My central angle is 120. I have, of course, 360 total. What that's allowing me to do is break this down into a fraction. Times pi times radius squared. Okay? Okay, hopefully there are many of us that can look at 120 over 30 or 360. I look at that as 12 over 36, which is 1/3. Then I've got a pi, and then I've got to figure out 42 squared. So 42 squared is this 1,764. Okay, and once again, I'm not going to take it times the pi button. So I'm basically taking 1/3 of 1,764, or I could take 1,764, and if I just divide it by 3, that's the same as taking by 1/3, I get 588, and then I keep the pi there. So my answer is 588 pi. You could put units squared. I think they actually have this in inches. You could also put inches squared behind this for a label. All right, next one. We have another sector here. Find the area of the sector. We got our formula. Leave your answers in terms of pi, the same situation. So we're going to take n, which is like our central angle, or the amount of degrees of our sector, which is 80, over 360, times pi times radius. Ooh, what's our radius? It didn't give it to us. Oh, but look over here. They kind of did. They gave a sneaky little piece of information that from here to here is 12. That's from the top of the circle to the bottom circle. So half of that would be a radius of 6 meters. So I'm going to put 6 squared. All right. This right here divides by 4. I would have, or 40, 2/9. Okay, I still have the pi, and I still have 36. I'm going to reduce that down a little bit, and actually, I'll let you do it one of two ways. 2 times 36 is 72 over 9 pi. Oh wait, 72 divided by 9 evenly, so that would be 8 pi. Okay, and that should technically be meters squared. All right, now let's just say this was a 72, didn't come out to be something that divided by 9. I would allow you to put a decimal, so you would have like whatever, it's 73 divided by 9, like 8.1 or something. I would let you put 8.1 pi. However, being that I'm the fraction teacher, I would love it if you just left it 73 pi over 9 if it doesn't come out nice and even like this one. All right, so this one comes out even, so my answer is 8 pi meters squared. All right, find the area of the segment. Okay, the segment is this shaded region here. And just because of the mathematics involved, we are going to go ahead and round to the nearest tenth here. But we can start off, and once again, we don't want to round until the very end. So we might want to leave things with pi until the very end. So, looking at this one, I have to take my n, that's the amount of degrees, over 360 times pi r squared, and then I subtract out that triangle so that I'm left with the shaded region. So it's going to be 1/2 base times height. And I might have to do several little pieces here. So n, in this case, is 150. And then I got to take my pi times the radius squared. 1/2, and actually, you know what? Let's do this in 2 steps. Let's do this part in a little bit. All right. 150 over 360. 3 goes into both of those things, so, or 30, I should say. Oops. Isn't there 5 times? This goes in here 12 times. So that breaks down to 5/12 times pi times 100. So really, I have 500 pi over 12. Okay, and I'm actually going to leave that like that for now, because I can calculate that later, and I'm just going to leave it. All right, now I'm going to work on this part right here. 1/2 base times height. Let's redraw this triangle a little bit bigger here. I have 150 degrees divided in 2 parts, because we've been doing that right now. You're like, oh yeah, totally, I'm going to do that. 75, 75, this is going to be a 10 out here. This will be a 15. 70, because this will be a right angle, so 75 and 15 is 90. And that gives me the 180 degrees. What I need to figure out, actually both things, I need to figure out this dotted line, and I need to figure out this base here too as well. All right, so I will go ahead and use a little bit of trig to figure that out. I'm going to go with, let's see, let's figure out this side first, x. Opposite and a hypotenuse. So I'm going to go sine of 75 is equal to x over 10. Okay, sine is opposite over hypotenuse. So this actually ends up being 10 sine of 75 equals x. So I don't think my calculator on this screen has that, so I'm going to go 10 on my calculator, and I'm sure you're all grabbing your calculators right now, and I'm getting 9 point, and I'm going to keep, this is where I keep my 4 decimal points, 6, 5, 9, 3. All right, that is just half of my base. So I'm going to take that times 2 to get the entire length here. Put that in blue. So this is actually 19.3185. So I've got minus 1/2 the base, which is 19.3185. All right, and then I have to find the height. Now I have a choice. I can either use my sine, cosine, tangent again. In this case, I would probably want to use cosine to find the height, or I can use Pythagorean theorem. I'll let you work with whichever one you want to. I personally am I think I'm going to use Pythagorean theorem on this one. So I'm going to take 10 squared, which is 100, minus, and I have to go back to this number, this 9.6593 squared, because I'm taking actually my hypotenuse minus my leg. So 100 minus 9.6593 squared, and then I have to take the square root of that number. Okay, and I'm getting, and of course maybe you're using trig on this, you're going to use 2.5880. 2.5880. Now I'm going to multiply all of that out, so 0.5 times 19.3185 times 2.5880, and I'm getting, oddly enough, 24.9981. All right, and now I'm just going to do all this in my calculator, 500 pi, and then I divide by 12. I get, by the way, 130.8997, and then I subtract out my 24.9981. I am getting, I better check my answer that I previously worked on, 105.9. Okay, and my label should be centimeters squared. Okay, so that's quite a bit there. Find the area of the sector, subtract the area of the triangle, and as you can see, there's going to be a little bit of work involved in that. That takes a little bit of time. All right, moving on to this next one. Let's give you another example to work with. All right, we know how to start. We've got n over 360 times pi r squared minus 1/2 base times height. And when I get this answer, I'm going to have to multiply it by 2 because I've got actually 2 sectors. One here and one here. So here we go. We have 360 degrees, but I have 5 triangles to work with. So 360 divided by 5 makes every one of these 72 degrees. But of course, I'm going to cut one of these in half. So now I've got a 36-degree triangle. All right, what am I going to be worried about? I need to figure out my radius. Oh, I have my radius. And I can also, eventually I need to find my height, I need to find my base. So here we go. 72 over 360. Okay, because I'm taking the entire angle right here. And then I'm going to take it times pi and times my radius, and we square that. Minus 1/2 base. I got to figure out this. In order to figure that out, I have to figure out this. Oh, goodness, what will I do? What shall I do? My radius is 4, so I'm probably going to use sine again. Sine of 36 degrees is equal to opposite, which is x, over hypotenuse, which is 4. So I go to my calculator, and I have 4 sine 36. X is equal to 2.3511, which means the whole amount is equal to double of that, which would be 4.7023. All right, I still need to find the height here. I need to work on this number right here. I can use Pythagorean theorem, which I think I'm going to do. I'm going to take 16 minus my x value squared. And once again, I'm not going to, you guys should be pretty good at doing this. I'm going to quick calculate that. And I'm getting 3.2361. So 1/2. The base is 4.7023. The height is this dotted line right here. It looks like I have an arrow drawn there, but it's actually for this number, 3.2361. Holy cow, look at all this math. This is craziness. All right. And then we calculate 72 divided by 360 times pi times 16. This part, and this is a good way to check to see if you're doing this calculation right. Go ahead and check it yourself. 0.5 and do the little pieces. 4.7023 times 3.2361, and I'm getting a 7.6086. Subtract those two, and I'm getting a 2.4445, which we're going to round. We're going to say our area for the segment is 2.4. Label, no, don't need one. You can put units squared. All right, and that should take care of that. And let me double check. I think I had something really close when I worked it out. Oh, I know what I didn't do. Oh, you almost had an opportunity to let me know that I was going to make a mistake. I have 2 sections, 2 little segments. So those 2 segments, I've got to double this. Actually, I should double this one, but it's going to come out the same. It's going to be 4.88, which I would round to 4.9. Yeah, so we're going to go 4.9. Units squared. Oh my gosh, I almost gave you an opportunity to get some extra credit, but no, this should be your answer. Okay. All right, there is one question. This is expected to be turned in. You can turn it on a half sheet of paper. Going to be looking for your work, going to be looking for your answer, and that'll be great. That concludes today's lesson.